everyone, welcome to this video about how to add and subtract integers. So I believe that everything in life, including math, is much easier when we love ourselves. So today I'd like to encourage you to find one or two things that you're grateful for and allow that gratitude to bring a little bit of extra love into your life. So take 2 deep breaths, give yourself some love, and let's make this math easy.
All right, so before we start adding and subtracting integers, let's first talk about what an integer is. So the whole numbers are numbers like 0, 1, 2, 3, 4, 5, 6, 7, etc., all the way up to positive infinity. And you can also have the opposite of the whole numbers, which would give you numbers like -1, -2, -3, and so on, all the way down to negative infinity. So the integers are basically a combination of these two groups of numbers. So they're all the whole numbers and all of the opposites of them. But they don't include numbers like fractions or decimals and things like that. So if you'd like to learn how to add and subtract those numbers, you can check out my other video on how to add and subtract negative numbers. So when we're adding integers, we have several different situations that we could have. We could have a positive plus a positive, we could have a negative plus a negative, or we could have a negative and a positive that are added together. And in all of these different situations, I like to use a positron and electron analogy to help me understand how this works. So positrons and electrons are subatomic particles where the negative charged particles are electrons and the positively charged ones are positrons. Now there's also other things like protons and neutrons, and there's a lot of other things that happen on a subatomic particle level in real life. So don't use this as a chemistry lesson. But if we use just the two basic particles of an electron and a positron, the cool thing is that when these two particles come together, they actually vanish. So positrons are kind of like a dark matter particle, and they cancel out electrons and they make them vanish. But if the positron and electron ever separate, then they pop back into reality, and an electron is the negatively charged particle and the positron is the positively charged one. So in any situation, there's an infinite number of positive and negative charges that if they were to separate, would become a positive and a negative. But because they're paired together, they have an overall charge of 0. So in this picture, the overall charge of the situation is 0 because all of the positrons are paired with one electron. And if I were to use this as an example to help me understand addition of positive and negative numbers, I could look at this and say, okay, I'm starting off with a situation with a whole bunch of positive and negatives that are paired together, giving me an overall charge of 0. And then if I put in 2 positrons, and then I add 3 more positrons, then the overall charge of this situation is going to be a positive 5. If I were to put in 5 electrons, then that would have a charge of -5. And if I added in 3 more positrons, then some of these are going to cancel out because this electron could combine with this positron and they would neutralize each other. This electron could combine with this positron and this one with this one, and all of those would cancel out, leaving me with a -2 as my answer because there were 2 electrons that didn't get a pair, or they didn't partner off with a positron. I could get something like this where I have a negative charge plus 8 positive charges, and most of those positive charges are going to stay, except one of them is going to neutralize with that negatively charged one, giving me an answer of positive 7. If I was to add together 2 negative integers, then I would have 2 negatives plus 6 negatives, which gives me an overall charge of -8. And so this is how we would add together all of these integers. And if you notice, when you have the same signs, like a positive plus a positive, your answer is going to end up being a positive number. And the number is going to be those two values added together. So like 2 plus 3 is 5. And the same thing happens when you add together two negatives. You do a negative 2 plus a negative 6. 2 plus 6 is 8, but it's negative because they were 2 electrons and 6 electrons, versus in this first example, they were 2 positrons and 3 positrons. If you have opposite signs, like we have here, then notice that the number part is subtracted because you had 5 electrons, and when you added in 3 positrons, the positrons canceled out the electrons, which is kind of like taking away. And so 5 minus 3 is 2, and it's a negative 2 because they were electrons, like there were more electrons left over than there were positrons. In this case, you still subtract them. You say, okay, I have 8 positives, and the negatives cancel out one of them. So 8 minus 1 is 7, but this time it's a positive because there were more positrons than there were electrons. So whenever you have the same sign, you're going to add the absolute values of the numbers. So like 2 plus 3 gives you 5, or 2 plus 6 gives you 8. And when they're different signs, you're going to subtract them, like 5 minus 3 is 2, or 8 minus 1 is 7. And the way that you determine whether it's a positive or negative is you look at which number, what sign the biggest number has. So like in this example, the biggest number was 3, and so you get a positive answer. In this example, the bigger number was -5, so you get a negative answer. In this example, the bigger number was 8, and so you get a positive answer. And in this one, the bigger number was -6, and so you get a negative answer. Again, remember, bigger than, the way that I use it, is different than greater than. But that's how you would add integers. So what about subtracting integers? What does that look like? So I'm going to go through each of these examples using this same analogy. So if I have 7 minus 2, that means that I'm going to start off with 7 positives inside of this infinite amount of positive and negative pairs, because there's even more positive and negative pairs than I could put on this page, but they all end up neutralizing each other and equaling 0. So the only thing that counts is what I'm adding in here. So I have a positive 7, and if I take away 2 positives, that means that I'm going to end up with 5 positives when I cancel out those 2 that I subtracted. If I have a situation like this, where I have 3 positives and I try to take away a negative, I actually have to take away a negative from one of the pairs because there are no negatives to take away up here. So I would have to take away a -1, which means that this positive is going to be part of these positives, and I end up getting an overall charge of a +4. If I have a situation like this, where I have 4 negatives, and I try to take away 2 positives, again, I can't take away from this step because there are no positives in there. And so I would take away these 2 positives, which means that these negatives are going to join with these 4 negatives, giving me an answer of -6. I could also do this if I had 2 negatives being subtracted. So if I had -3 minus a -5, that would mean that I would need to get rid of 1, 2, 3, 4, 5 negatives. And these 2 positives would be what was left over, so my answer would be +2. So when you're subtracting integers, you can get lots of different results depending on what the numbers are. The easiest way that I've found to do this is, rather than writing it as subtraction, it's easier if you write it out as addition of the opposite. So for example, you could say 7 minus 2 is the same thing as 7 plus a -2. And that's going to create the same result as subtraction, But it makes it a lot easier when you have situations like this, because you can say that 3 minus negative 1 is the same thing as 3 plus a positive 1, which makes it a lot easier to get that answer of 4. Or you could do negative 4 plus a negative 2, which makes a lot more sense why that's a negative 6. Or you could go like negative 3 plus a positive 5, and that makes sense why that would end up being a positive 2. So in my opinion, the easiest way to subtract integers is to turn it into addition by adding the opposite. And if you want to know more about why you can do that and why that is possible, you can check out my video about how to subtract negative numbers, and that goes into more detail there. But the summary is when you're adding integers, you want to first identify what the signs of each part are, like whether they're positive or negative. And if they're the same signs, then you're going to add the absolute values together. And if they're different signs, you're going to subtract the numbers. And then the part that had the biggest absolute value determines the sign of the overall answer. With subtraction, I recommend just rewriting subtraction as adding the opposite so that it makes it easier. Because in my opinion, addition is way easier than subtraction is. Especially when you involve negatives. So whenever you have subtraction of positives or negatives, I would just think about it as adding the opposite of that thing. And again, you can check out my subtracting negative numbers video to learn more about that. I hope this video was helpful. Let me know how easy this topic was for you by typing a number in the comments below, and then subscribe for more easy math videos. You may also want to check out my negative numbers playlist to learn more about negative numbers. And if you'd like more help with adding and subtracting integers, then go to mathtutoringonline.com to ask a question or book a one-on-one tutoring session. See you soon!